All right, so let's go ahead and look at our next example here, example 9.4. Okay, so we're going to see what force a bicep muscle would exert to hold the forearm and its load, which is a textbook in this case. Okay, and then we're going to compare that with the force, with the weight of the forearm plus its load. Okay, so our first section here, we need to just calculate this force here, this FB. So FB is what we want to know. Okay, and we don't know a few of these forces. So if we look at this diagram, we can figure out the weight of the book. We can figure out the weight of A here, but we can't figure out our force F sub E, which is the force due to the elbow. Okay, so then if we don't know that force, let's go ahead and get my pen and call that point here our pivot point. Okay, because remember in our last ones, that pivot point, we kind of ignore whatever force is right there in the meantime. Okay, we're going to go ahead and use our equilibrium equation again. Our net torque equals 0. Okay, so we can go ahead and set this up same way that we have been. So our net torque for our first point here, so we'll call that T or tau sub B plus, but this is in the negative direction, our tau for our weight, A, I should just call it A, since there's an A and a B, A minus tau at B should equal 0. Okay, so our first one, remember our equation is R times F times sine theta. So this is going to be R, R1 we can say, times FB, which is our unknown. Okay, and sine theta is just going to be 1 since it's at 90 degrees. Okay, then we have, I'm going to go ahead and move these to the other side. Okay, so this is going to be R2 times our force, which is WA. Okay, and let's see here. Okay, so we have our weight A, and then plus our 3 times weight B. Okay, so then if we solved for our force here, we'd get R2 WA plus R3 WB divided by R1. Okay, and remember weight equals mass times gravity. Oops. So we can put that in, mass A times gravity plus R3, mass B times gravity divided by R1. Okay, so we can go ahead and plug that in, or plug everything in. R2 is 16 centimeters or 0.16 meters. Mass A is going to be 2.5 kilograms times 9.8 plus R3, just 38 centimeters, so 0.38 meters times our mass, which is 4 kilograms times 9.8. Okay, and that's all going to be divided by our R1, which is 4 centimeters or 0.04 meters. Okay, so you can plug that into your calculator. Let's see. 0.16 times 2.5 times 9.8 minus, or plus, sorry, 0.38 times 4 times 9.8 divided by 0.04. And we get our force is equal to 470 newtons. So this is our force exerted by our bicep. Oh. Spinning wheel of death has arrived. It's not good. Hopefully it'll go away. Please, please, please. Okay, so that is going to be our force exerted by our bicep here. Okay, and the next part, they wanted us to compare that with the weight of our two objects. So what you would do is you'd take that value and divide it by the addition of the weight of the two objects. So weight A and weight B. And so we can do that, I guess, without writing it out. Since this has no frozen, take that and divide it by, what are the masses? 2.5 and 4 times 9.8. And our it's still not working. Our factor then would be 7 times. So we can, or this person at least, can lift or exert a force that's 7 times more than the weight of those two objects put together. Okay. So I'm going to go ahead and stop this and hope that it comes back here in a minute.